Okay, welcome again to this lecture series of multivariable calculus. So in this lecture, I will talk about the differentiation. You already know about the limit and the continuity. Now we'll talk about the differentiation. So in the case of single variable, you already know how to find out the differentiation. In the case of multivariable, we'll talk about it is a partial differentiation. Okay. Now, how the partial derivative can be termed in the terms of the multivariable? So, it is one sort of ordinary differentiating with respect to one of the variable when all the remaining variables are held constant. So, what I mean that suppose if you have one function, let's say z equal to f of xy, and we are differentiating this function with respect to one independent variable, let's say x, then when I differentiate this function z equal to fxy, then I should consider the other independent variable y, that is a constant. Okay. Now, what are the notation? So when we are differentiating this function with respect to x, then I will already tell you that differentiating of the z with respect to x, y, the other independent variable, should be treated as constant, and it will be called the partial derivative of z with respect to x. Right? We are keeping constant and differentiating this function with respect to x, then it will be partial derivative of z with respect to x. And how will denote these things, the partial derivative of z with respect to x? So it can be denoted in this way: del z by del x. So if you have the single variable y equal to fx, basically you denote this term is dy dx, right? Now here you have the two independent variable, so it is denoted del z del x, okay, or del f del x, because z is a function of xy, so del f del x. Another way, that is also shortcut way to denote the partial derivative of z with respect to x. So it is denoted by f and suffix x, means that partial derivative of this function z with respect to x. And another way, d x suffix x and f. Okay. Now similarly, if we there is partial derivative is there, the z with respect to y, right? So we are differentiating with respect to y instead of x. Then similarly, it will be del z del y, del f del y. So only independent variable are changing in the term, and similarly the fy suffix, okay, and dyf. Now let's check some example of partial differentiation. Suppose we have this function z equal to x plus y. Now what, and I want to find out the both the partial derivative. Okay, so means I have to find out what is del z del y or del z del x. Both the partial derivative I have to find here. Okay, so first I do this function z equal to x plus y, then del z by del x, del z del x, that will be del z del x and x plus y. Now I already told you that when I differentiate this function, I'll create another independent variable, that is y here, as constant. So this will be constant. So if I differentiate this function, then it will be 0. So then this term will be 0 and this will be 1, right? So del z del x will be 1. Similarly, if I differentiate this function with respect to y, then x will be constant, y will be variable. So then it will be 0 plus 1 because the first term will be 0 and second term will be 1. Okay. Now second example. Suppose we have this function z equal to x square plus y, and I have to find the partial derivative of this function. So I first find out the partial derivative of this function with respect to y. So here I will treat that x as constant, right? So I'll treat the x constant. So this term will be 0 and this term will be 1, right? Now in the case of partial derivation with respect to x, then y will be constant and x will be variable. So x square, if I differentiate x square with respect to x, then it will be 2x, right? So the result will be 2x. Now the third example, where we have z as x square y. So in the case of partial derivative with respect to x, so here y is not a variable. Okay, remember this term when you are differentiating in the partial way. So y you can take it out as a constant. So y equal to del x square del x. And you know the differentiating of x square with respect to x is 2x. So result is 2xy. So similarly, if I differentiate this function with respect to y, x square will be constant. So x square will be come out here, and del y that will be 1. So x square 1. So result is x square. Now the fourth example. Suppose if you have this function x square by y square, and the first we differentiate this function with respect to x, then y is constant. Okay, so I can take out the y outside of the differentiation, then it will be 1 by y del x square del x. So del x square del x, it will be 2x, so it will be 2xy, 2x by y. Similarly, when I differentiate this function with respect to y partially, then x square will be constant, so I can take out x square outside of the differentiation. The differentiation then 1 by y with respect to y, it will be negative of 1 by y square, right? So here result will be minus x square by y square. Okay, thank you.